Welcome back. In the last section, we set up the model, ops resolver and the tensor arena. Now comes the critical step, creating the interpreter. The micro interpreter is the engine that runs our model on the microcontroller. It combines three things: the model itself, the operator resolver and the tensor arena we allocated. We create like this: the TF Lite Micro interpreter, model resolver tensor arena, and the arena size and also the error reporter. So once created, we must call this allocate tensor a time. This assigns slices of the tensor arena to the each tensor in the module, inputs, outputs and also the intermediate layers. So think it is like a teacher assigning seats in a classroom. Every tensor gets its own place in the memory. Once the seats are assigned, learning can begin. Now let's confirm that our input tensor matches what our model expects. Input tensor. Our Hello World Series model is very simple. It expects a single floating point input. So, but in TensorFlow Lite, this scalar is stored as a 2D and the shape is like braces 1, 1. So, on the type is KTF Lite float 32. It can be accessed via this code TF Lite tensor pointer input interpreter dot input. So it's crucial to confirm it matches what the model was trained on. If the input type or shape doesn't match, the inference will fail and give you garbage values. So like it's making sure that the key fits the log before turning it. Wrong shape, wrong type, nothing works. Now that we have the input ready, let's see how our inference actually works. Running inference. Inference is the process of passing data to the model to get predictions. For each cycle, we do 3 steps. Write the input value, input the data, and call the interpreter. Interrupt, we are invoking the interrupt. Check if the return value is TF Lite okay. That means it's success. So each run update the output tensor with the predicted value. In simple words, we had the model an x value, it thinks for a millisecond and then hands us back the predicted sign. That's it. So now we'll see how to fetch that prediction. So reading the output. Once the inference runs, the result is stored in the output tensor. So we have to fetch the output sensor and read the predicted sign value. The scalar results is available for logging or display only. So fetch like this: TF Lite sensor output and interpreter dot output. So the output data is mostly in the float, which is predicted value. This gives us the model predicted sign value for the input x. Each call updates this sensor, so you need to keep older results. You should copy them out as soon as possible. Finally, the prediction is passed to the handle output, which formats or displays the result depending on the device. This is where the abstract math turns into something we can see as logs or LED blinking or as a display output. So always remember, the input goes to the input tensor, output goes to the output tensor. That's what you have seen for till now. Once you have the output, you can use any applications to do with it, and exactly this defined in the main functions.cc. So the main functions.cc setup and loop operations we have here. Let's tie everything together in the code. So this file mirrors the Arduino sketch style, setup and the loop. So setup runs once to initialize everything, loop runs forever, continuously generating the inputs and processing the outputs. In setup, we initialize the error reporter, map the model and check the version, and create the interpreter and allocate the tensors. Finally, we set pointers for input and outputs. Loop. We generate the next x value stepping across 0 to 2 pi, run inference to get this y in the model, and call out handle output x comma y to display these results. The increment counter will wrap around and as soon as the output is ready, we'll copy this output for our data logging. The loop is the heartbeat of the Hello World app. It shows how simple the structure is, yet how powerful the same template works for audio, keyboards or sensor monitoring. Thank you for staying with me through this section. In the next part, we'll explore main.cc and output handler.cc, where we'll see how everything runs on the Arduino.